I have a question on the rearrangements. If you guys are okay, if you're already good with them, we don't have to go over it. But like when we use hydrogen or hydride and methyl shifts, and what are the rules for doing it? Like I'm just kind of unclear still on that.
Okay, if you go for the rearrangement part again, you're gonna see. This is how I like to think, and I don't know how the book teaches it, but I have that molecule, and I have a carbocation here, right? And then I think, if I do a metal shift, making one of these metals here move to that carbon, my final product will be this.
And why can it shift over?
Because this is a secondary carbocation, this here is a tertiary carbocation. And remember, tertiary carbocations are more stable. So I'm looking for more stability in my molecule, and I say, well, I could have one of this metal shift into this carbon, making the tertiary carbocation that is more stable.
Is that because the force of the hyperconjugation? Is that's why the molecule is stabilizing? Is that how it pulls the methyl over to the secondary?
It could be. I'm not 100% positive about that, but it could be. Could be one of the reasons. This guy has so much stability, and it could just, yeah. And I could have the same thing happen in this side. Well, not really.
That's the primary.
Yeah. Now I have the second situation there, and I have the same carbocation here. Now I think, well, if I make one of these metals moving for this side, I got a that.
The same molecule.
It's the same thing. It's still the secondary.
Switching.
Secondary. So now I think, well, there's another shift that I could do if I have a hydrogen here, and I really do have, because carbon 1, 2, 3, 4 bonds. If I do this shift, now I move it, my carbocation from a secondary substrate to a tertiary, which it is more stable. You can claim this, the moving, the shift, if you're making a molecule more stable, if your carbocation is more stable.
So, in what mechanism do we use the shift? Is it in any time we're trying to make it more stable?
Anytime, yeah.
Okay.
Yeah, they
Today,
should have taught us that when we started learning mechanisms. So we have to go back and apply that to all the other
Yeah.
mechanisms that we learned.
SM1
Okay.
and like B1, right? Because
Yes.
they're from carbocation.
Yes.
okay.
So when I'm getting my final answer, suppose I'm dealing with this guy here, I say, well, I'm working with substitution there. I say, well, suppose I'm adding this BR minus. I say my BR could come and add it there. It could be one of my products without any shift. Or this guy could move, and I also could make that guy there.
So which one's more correct? Are they both?
I would say this one is my major, this one is my minor.
I'm still missing that. I don't understand.
And the reason for that is because this is a secondary carbocation,
Uh-huh.
so this is a tertiary carbocation. What one is more stable?
Tertiary.
I give preferential to the tertiary as my major.
Okay.
So when if you go back to SM1, you were gonna use like both. It's like before we just replace the alcohol and put on the whatever we had. So now we have to go through the shifting, and then
You need to go through and check if you do,
if you could get a more stable one.
yes, if you can, then you do it.
Okay.
But this is how I like to think. Well, secondary, tertiary takes priority. It's more stable. So I can claim that my tertiary is my major. Except if she gives you some, I don't know, reason for not. You're gonna see later on that some reaction she will say, even though we expect this guy to be the major, it is not the major. And one of the reasons is because blah, 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 blah. But the general idea is that tertiaries, more stable, secondaries, least stable. And the thing she would say that is because, the BR is a big atom. And you have a metal and a metal that has a lot of hydrogens. So these guys could be just, close to each other. And then you have some sterics going on there. So it would be hard to place this guy in there. So then some reaction you say, well, because we have too much in there. Suppose I have here, instead of a metal, I have a third butyl. And a third butyl there. This guy's not going to be added there.
Yeah.
No way. You have carbon, 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 and place a big atom there. It's not going to happen. But for these situations, she would tell you, we expected this to be the major, but it is not. And she can say, give me the reason why. And most of the time, the reason is because sterics.
So when we're going through a mechanism now, say we're given a molecule, the thing to do is figure out when it's in an unstable state or it's a carbocation, how we're going to make it the most stable before even adding the halide or whatever else.
Yes.
Okay.
I would say, I got in my carbocation step, my step number 2 for E1 chemistry, and I say, well, I could have a rearrangement. Then I do the rearrangement and then I say, this is my product. Usually we could have 3, 4, or 5 different ones, just depending on the molecule. This is really simple one, it's really obvious to see. But remember, to do the shift, you need to be, what they call those 2 carbons?
Secondary.
And they have a specific word, and I think she mentioned to you.
What's the question?
What is this 2 carbons called?
Oh, the
They're
alpha
what?
and beta?
Mm-mm. They're called what? Vicinal carbons. And she used that in exam. Sometimes she just throw in a quiz,
Doesn't mean they're not.
She can say adjacent carbons or
Oh,
vicinal. It's the
like
same
next
thing.
to each other.
Yes, it's neighbors.
Oh, I had a question about, there were, it was like the first 2 questions in the homework. They were using the words like allele and vinyl and iso.
Vinyl,
She didn't go over it in class, but it's in the book, so.
you need to know that.
Right, so could you, are they just like the.
Yes. I think, Leo, you have like this. I don't remember. It is in chapter 5, right?
Yeah, I
Yeah,
think
it's
the first,
at the beginning.
like the second page or something.
These 2 guys, vinyl and allele, will be
And it was-
showing up over and over and over
It
and
was
over
like
and over and over.
isopropanol. So they're just like, do they have double, what, I don't know if they look.
What are
I think it's
they?
on the first page or the second page.
The first and second page?
Yeah, it was like way towards the beginning, but like I saw them and I was like, I have no idea. So we just haven't.
Oh, here. Yeah. So, CH, this guy, and then H2C double CH, CH2, this guy. Alright. Yes. And then H2C double CH, CH2, this guy. Okay, this is like just branch set that can show up in your molecule. This one has a specific name. It's basically what the book is showing you is that the connection will happen in here, and in here. So if you have the connection, suppose I have my chain there, and then you have 1 carbon, a double bond, and CH2. This is the vinyl. If you have a connection here, CH double CH2 allele, and if you have a connection here, And then I have a CH3 and a C double O CH2. This is the isopropanol. It's just like memorize it. Because this will show up, and we actually, I think in chapter 7 or 8, we have some chemistry we do with these two guys. Because this bond moves to there, and now we have a new
So
chemistry.
it's vinyl and allele or
Allele
allele?
and the iso. These two here, because this is why I'm saying, you know, if you know them, because they will show up again with chemistries that we can do with these two guys.
I don't know, did you guys have another question or? Because I kind of would like to walk through an E2 mechanism and make sure I'm understanding E2 mechanism.
Okay.